Something extraordinary just slid into our solar system, and it refused to behave like anything we've seen. 3 Atlas swung past the sun, and instead of acting like a normal comet, it flashed an eerie blue light, drifted off its predicted path, and showed signs of acceleration that don't match the usual outgassing story. The real moment of truth is coming on December 19th, 2025. Telescopes will either spot a massive debris cloud that explains the physics, or they won't. And then everything we thought we knew about comet behavior gets thrown into question. On October 29th, 2025, 3I Atlas swung closest to the sun, and instead of quietly steaming away like a normal comet, it erupted in a way that stunned observers. Solar telescopes and space observatories tracked a sudden intense brightening, and even stranger, the light shifted toward the blue end of the spectrum, bluer than the sun itself, which is not how ordinary comet dust or gas behaves. Instruments that normally study the sun saw this unexpected flare, and amateurs with backyard gear reported the same odd colour and intensity changes. That blue flash told astronomers something fundamental was different about the materials or processes around Atlas, and it set off a chain of follow-up measurements that revealed even more anomalies. But that wasn't the whole story. Then the orbit trackers raised the alarm. High-precision measurements showed 3I Atlas sitting about 4 arcseconds away from where models predicted. That tiny angular gap translates into a real, measurable, non-gravitational acceleration. The object was being pushed in ways gravity alone can't explain. For ordinary comets, the usual culprit is jets of gas and dust blasting off the surface and nudging the nucleus. But for Atlas, the math says those jets would have had to carry away a huge fraction of its mass, roughly 15% or more, on the order of billions of tons. If that much material was lost, it should be obvious as a vast debris cloud trailing or surrounding the object. Astronomers are left with a stark question. If outgassing caused the push, where is the missing mass? Spectra and optical measurements added a whole new layer of weird. When scientists broke the light from 3I Atlas into its components, they found metal ratios that don't match typical cometary material. A surprisingly high nickel-to-iron proportion that looks more like processed alloys than primordial ice rock mixtures. At the same time, the object appears almost starved of water compared with ordinary comets. Only a tiny fraction of its mass seems to be volatile ices. Even stranger, polarized light studies showed an extreme negative polarization signature. In plain terms, the way Atlas scatters and twists starlight is unlike anything seen before. Those chemical and optical fingerprints make the dirty snowball model hard to defend, and they push us to ask bigger questions about origin and composition. But that's not the end. When you add these findings to the orbital oddities and improbable timing, the list of puzzles grows even longer. If the chemistry and colours weren't strange enough, the path 3I Atlas took through our solar system stirred even more debate. Interstellar visitors normally barrel in on random inclinations, cutting across the planetary plane at steep angles. Atlas didn't. It came in on a retrograde orbit that just happened to be aligned to within a few degrees of the same thin disk where our planets orbit. The odds of a foreign object sliding into the solar system on a backwards path but still hugging the planetary plane are extremely small. It's like someone throwing a dart blindfolded backwards and still hitting the center line of a target. Then there's the timing. As Atlas moved inward, its trajectory brought it uncomfortably close to Mars, Venus, and Jupiter, almost as if someone plotted a tour through key parts of the inner system. Even stranger, it became invisible from Earth right as it passed perihelion, a moment when scientists most wanted eyes on it. That blackout wasn't caused by our planet's rotation or a random angle. It was a geometric coincidence so precise that several researchers flagged it as statistically remarkable. Stack those on top of Atlas's physical traits. It's far larger than the 2 other interstellar objects we've confirmed, yet faster as well. In the natural universe, size usually works against speed because more mass takes more energy to accelerate. But Atlas behaves like something that's both massive and highly efficient at moving. Not impossible, but extremely uncommon. Scientists like to talk in probabilities, not gut feelings, and when they run the numbers, the combination of its orientation, timing, size, and speed lands in territory that is vanishingly unlikely to be coincidence. In short, the deeper astronomers look, the less Atlas fits into familiar categories. And still, the strangest test hasn't happened yet. Here's where the story stops being speculation and turns into a measurable, unavoidable experiment. When ALMA and other observatories detected Atlas drifting 4 arcseconds from its predicted orbit, the only conventional explanation was powerful outgassing, jets of material blasting off its surface and kicking the object off course. Astronomers crunched the numbers. To move something this large by that amount, Atlas would have needed to shed billions of tons of material. That's not subtle. That kind of mass doesn't whisper into space. It floods it with dust, vapor, and rocky fragments spreading across millions of kilometers. So scientists laid out a simple test. If Atlas lost that much mass, there should be a huge debris cloud surrounding it. Not a thin haze, a vast envelope of material easily detectable with modern telescopes. And if that debris exists, the perfect time to catch it will be December 19th, 2025, when the object makes its closest approach to Earth during this journey. Even at roughly 1.8 astronomical units, our instruments are more than capable of spotting the fallout of a catastrophic mass loss. One giant cloud, the conventional explanation holds. But if there's no cloud, if Atlas is clean, intact, and still accelerating, then the laws scientists rely on to explain comet movement are missing something. Something big. That's why this winter is so important. There's no press release wiggle room, no philosophical debate. Telescopes will look. They will either see the debris or they won't. And whichever way it goes, the story changes overnight. This is where emotions flare. Harvard astrophysicist Avi Loeb took heat for suggesting that scientists should not rule out unconventional explanations. He's not claiming Atlas is alien, artificial, or technological, but he is saying that when the data doesn't fit the model, science demands we consider new possibilities instead of forcing old answers. His critics accuse him of being too speculative. His supporters argue he's simply being honest about the evidence. The debate is louder because the stakes aren't trivial. If Atlas turns out to be a new type of natural object, something radically different from comets and asteroids, then we've discovered a whole category of interstellar visitors we never knew existed. That alone would rewrite textbooks, reshape origin theories, and force scientists to rethink how matter forms and travels between stars. But if December's observations show acceleration without mass loss, that opens the door to wilder ideas. Something mechanical, engineered, or stabilized by unknown physics. A probe, a damaged fragment, a relic from a civilization we've never seen. Scientists aren't jumping to that conclusion, but they aren't ignoring the possibility either. Because for the first time, we're not dealing with ancient fossils or faint signals. We're watching something real, close, and in motion right now. And that's why this mystery has captured the public. For decades, conversations about extraterrestrial life were theoretical. Atlas is different. It's here, it's measurable, and in a matter of weeks, it will either give us a natural explanation that expands our understanding of the universe, or it will refuse to fit into the natural box at all. As the date approaches, observatories around the world are already reserving telescope time. NASA, ESA, and dozens of university teams are preparing instruments to watch Atlas during its closest pass. Even amateur astronomers with high-quality backyard telescopes are gearing up. Because if the debris cloud exists, it will be visible to more than just the big agencies. What makes this moment different from most scientific mysteries is transparency. Anyone can point a telescope at the sky and check. This isn't a secret military project, and it's not buried in data only supercomputers can read. If Atlas arrives looking shredded, surrounded by drifting rubble, then the mystery is solved. A strange object, yes, but still natural. But if it slides past us clean and intact, continuing that unexplained acceleration, then the silence will be louder than 1,000 headlines. Because at that point, every major space agency will have to answer the same question. What is pushing 3i Atlas? No scientist, no skeptic, no official can hide from a result that plays out in open sky. And that's why this story is becoming global. Not because people expect aliens, but because for once there's a simple test and a clear outcome. Everybody gets to see the truth at the same time. Whether Atlas turns out to be a new kind of natural visitor or something far stranger, this moment matters. We are watching the first close examination of an interstellar object that refuses to play by the rules. This is how science moves forward, not by ignoring anomalies, but by chasing them. On December 19th, 2025, we get answers. Not guesses, not theories, evidence. So mark your calendars, follow the observatories, watch the sky if you can. Because what passes us this winter might be the most important object ever seen coming from beyond our sun. Whatever the result, one thing is certain. When 3i Atlas makes its closest approach, the universe is about to tell us something. And for once, the whole world will be listening at the exact same moment.